Hi and welcome to our notes on section 3.2. Today we will be exploring the Pythagorean relationship. But let's review for a second here. Last lesson we learned about perfect squares and prime numbers, so let's put a circle around all the perfect squares between 1 to 10. So 1, 4, and 9 are all perfect squares because 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. And now let's put a box around all the prime numbers. Well, 2 can only be divided by 2 and 1. 3 can only be divided by 3 and 1. 5 can only be divided by 5 and 1. And 7 can only be divided by 7 and 1. So 8 is not a prime number, for example, because it can be divided by 8, it can be divided by 4, it can be divided by 2, and it can be divided by 1. So a prime number can only be divided by itself and 1. Alright, and you already know as well about area, and so if the area of a square is 289 millimeters squared, what's the length of each side? Well, we know that for a square all the sides are the same length. So we'll call this length L, and we know that area equals length times width, but if the width and the length are the same, then we can just say the area equals length times length, because length and width are the same. So here, area equals something times itself can also be expressed as squared. So if we know that the area here is 289, that equals L squared. If we want to get rid of that little square there, the opposite, kind of like multiplying, dividing, adding, and subtracting, the opposite is to take the square root. So L equals the square root of 289. So the length then would equal, you can type that into your calculator. I don't expect you to memorize it, but you might after a while, because we will be looking at the same numbers over and over again. But the length there would be 17 millimeters squared. If you want to check your answer, then you would say, well, area equals length times width. Length and width are both 17, so 17 times 17 should equal 289. So today we're going to then focus on length and these ideas with area and of squares, but we're going to talk about a special kind of triangle called a right triangle. And why is the right triangle so special? Well, it has an angle that is 90 degrees, and a 90-degree angle is also called a right angle. Right triangles show that they have a right angle by marking that with a small square. So here would be the square to show that this triangle down here is a right triangle. Each side to the right triangle also does have a special name, and we're going to label the names below. The name of the side that's opposite from the square is called the hypotenuse. So I'm going to write that here, hypotenuse. And the other two sides are called the legs, one leg, two leg. So the longest side is called the hypotenuse. Hypotenuse. And the hypotenuse is always opposite from the right angle. This is very important for you to notice that the longest side, I'll repeat it again, is called the hypotenuse, and it's always opposite from that little square showing us where the right angle is. Alright, the side lengths of the triangle are related to the squares that form around it. Remember what we learned about area. If area equals length times width, or in this case, since they're all squares, area equals length squared, then this length here is a length, that's length, that's length, and subsequently this one is a length. So this length B is the same as L. That's the length of that square, and if we figure out what the length of this leg B is, then we can times that by itself to get the area of this square. Alright, let's try this a little bit. So the side lengths are also related to each other, and this relationship is called the Pythagorean relationship. Pythagorean relationship. So if this box here, or this length is called A, then this is called A, and this is called A, and this side is called A. So just like area equals length squared, the area of this square is a squared. Same thing with this. If this length is b, then this is also b, this is also b, and this is also b. So the area is b times b, b squared. Same thing with this last one, the hypotenuse, the longest one. If this side is c, then this side is c, then this side is c, then this side is c, and the area is c squared. So we can say this Pythagorean relationship, we can write this as an equation. A squared plus b squared equals c squared. This is not the same as a plus b equals c. That is not correct. You must have the little squares on top of all three letters. A squared plus b squared equals c squared. Now it's also important that this c squared is the area of the square whose length is the hypotenuse. Hypotenuse length area. So that's really important. The hypotenuse is the one that is c length, and c squared always must be the square that makes your little triangle. So these squares here that are all on the sides of the triangle, you could just think of it like drawing three squares all together and then see that when they come together they can make a triangle in the middle. So that's all we're doing. We're just taking three really nice squares and then arranging them so they make a triangle in between them. And each side length is related to the triangle and related to the squares. So we can figure out the lengths of the triangle sides by knowing the area of the squares. So let's try a couple examples here because this is a little bit tricky. A triangle has the lengths of 5 centimeters, 7 centimeters, and 9 centimeters. Draw the relationship between the lengths of the triangle sides and the squares that they form. Okay, so the first one, 5 centimeters. Oops, 5 centimeters. The next one, let's maybe draw over here, a little bit longer, 7 centimeters. And then here, this one's a little bit longer still, 9 centimeters. So here's our triangle. It's a right triangle. Then, and the three squares form around there, and each square has a length of either 5, 7, or 9. What are the area of the three squares? Okay, well the area is just length squared because they're squares. So if it's squares, it's length squared. If it's a rectangle, it's length times width, but we're dealing with squares this chapter. So 5 centimeters times 5 centimeters equals 25 centimeters squared. So that's the area of this square, of that square. The area of the next square would be 7 centimeters times 7 centimeters, which would give us 49 centimeters squared. And the area of the last one would be 9 centimeters times 9 centimeters, which gives us 81 centimeters squared. So those are the three areas. And the last question, C, is this triangle a right triangle? Yes. And now we have to say because it has a 90-degree angle and it has two shorter sides called legs and one longer side called the hypotenuse, and three squares form around it. So I'm going to say yes because it has a 90-degree angle, three squares form around it. Alright, last example for today. A triangle is surrounded by three squares with the areas of 225 centimeters, 289 centimeters, and 64 centimeters squared, all squared. What are the lengths of the sides of the triangle that these squares form? And which length is the hypotenuse? So this is a right triangle. What are we going to do here? Well, to figure out A, what is this A over here? This is B and this is C. To figure out A, we need to figure out what the length is based on the area. So if area equals length squared, then we can figure out, if we know the length, if we square root both of these, length equals square root of the area. So for the first one, the first length A equals the square root of 64. And if you type that into your calculator, you get 8 centimeters. For B, this is, the length would be the square root of 225, and that length would give you 15 centimeters. And for the length of C, the opposite of the squared would be the square root, so square root of 289 gives you 17 centimeters. So those are our three lengths. A is 8 centimeters, B is 15, and C is 17. Now it says which length is the hypotenuse. The 17 centimeter length is the hypotenuse. And we know this, one, because it's the longest length, and two, because it is the length of C, the longest side that is opposite from the right angle here. Alright, so that's our introduction to the Pythagoras relationship, the Pythagorean relationship, a squared plus b squared equals c squared. We are going to explore this not only in class tomorrow, but for a few days. So please come to class with some questions and ready to learn.